Hello, my name is Henry Peltier. This is my completed lane detection algorithm for homework 5, specifically for problem 1 for ENME 435. So we're going to start. I'm going to show off the code a little bit, and then I'll show off the algorithm and the kinds of lines that it shows for both test video 1 and 2, as well as determining explaining some of the faults in the code, as well as ways that I could improve it in the future. So let's just get right on it. We're going to go ahead and switch to Pawnee, which is my IDE of choice. So first, most of the code here was actually covered in the lecture. So the only thing that wasn't covered in the lecture here was the grab frame, although it was shared in one of the modules. I had made this attempt to dynamically allocate the file name. Unfortunately, I really didn't figure out. I'm sure I could have done it with changing the string characteristics or anything like that. But essentially, all of these definitions are done via the lecture notes. The only thing that is not covered by the lecture notes is this mean algorithm here. And I changed the Huffline transformation in order to be able to display the left and the right lane as different colors as was required for the homework. In our main function here, we have a counter, we have the video capture, and we have it grabbing a frame. We have Y and Z, which I don't think I actually ended up using in this. I tried to take inspiration from the GitHub, but I actually didn't end up using it. We go through the basic detection pipeline, snipping it, masking it, thresholding it, blurring it, edging it, and then finally getting the actual lines, which is this function here, which describes the Huff line for the any individual plane. And then we set up these empty arrays in order to start gathering average data. This was covered in the lecture as well. The only thing that was not covered in the lecture was the section right here, which basically states that if rho is greater than 0, then we say it's the left lane. And if rho is less than 0, it is the right lane. We can tell this because if it is in the left lane, it is going up the screen, therefore it has a positive slope. And if the arrow, or if the line is going down the screen, it has a negative rho, and therefore it must be on the right lane based on a camera perspective. From there, we apply that to our mean filter and finish off by showing the snip of everything else. So we have the left line applying the left line to the snip, and the right line applying to the snip. And then we have it waiting for 25, CV2.wait key 25, just so we can get a good view of what's going on. So now we hop right on into Anaconda. I already have everything activated, and then we run the file. If it run, and you can see here that the lane lines are going straight and they're following pretty well. For the most part, I think the algorithm works decently. The only issue I would have is that on dashed lines, we have that blank every now and then, which can be problematic in the future, as well as the fact that the algorithm, as you just saw right there, gets pretty confused when a car enters the frame or it identifies something that's not necessarily masked. And when there's no lane, it doesn't detect anything. And then here we see, especially with the very fine dashed lines, it does not work exactly very well. But as we're moving right along, it's able to detect the lane pretty well. In the future, I think it might be beneficial to apply a different function. And here we see it going a little crazy because it's identifying the white pixels of the truck. In the future, I think it would be beneficial to have some sort of algorithm that could detect the center of the lane, so that if there's something in the center of the lane, you know that there's not going to be a lane line there, unless, of course, the area is under construction, but that's probably the point of human intervention. But nonetheless, the algorithm works decently. I do think it should work better, but nonetheless. It works decently well. I think, again, if I were to say it would be much better, should there be additional masking factors that would improve the functionality of the lane detection algorithm. And now we're going to move on to the second test video. Test video 02. Let me make sure I have that saved. I believe I do. Test video. All right. Test video. We're gonna run that. And this is where we get really into the differentiating and lighting. Using the mask and the thresholding values that we have, that I have currently set up, which was covered in lecture, we can see that the lines are pretty wrong. It's covering the right line decently, kind of. Unfortunately, again, because the brightness is lighter, the mask isn't working as effectively, and therefore you're getting a wrong indicator of what's happening. Should the for this video in particular, it would help to dynamically allocate the masking values, maybe through the color picker algorithm or something to that nature. And there we see it's getting confused by the vehicle that is on the path. This is similar to the other video in the sense that it might be beneficial to have an algorithm that could dynamically allocate brightness, interference, noise. That's something that I think would be definitely beneficial. And yeah, I think that would definitely be the idea of lane detection is very cool, but I also believe that although the algorithm itself works to a decent extent, I believe that the algorithm can be very much improved to allow for dynamically allocated brightness factors, dynamically allocated interference factors, to determine where the lane is, what the vehicle should be doing, and how it should be doing it. To a certain degree, I also acknowledge that a certain point of inputs should be required for this system. Perhaps maybe an interface with a weather app, for example, to determine how sunny it is outside, or what the fog looks like, or what the humidity factor is. Some things of that nature would be very beneficial to be able to input into the code in order to make it more applicable to other situations that are outside of the typical purviews of what we do. But yeah, so this is my homework 5 problem 1 lane detection algorithm, and I hope you enjoyed.